And let's continue with session 3 labeled Looking Ahead. We start with Martin Koons, CMO and founder of Cerabyte, presenting Building Persistent Archives of the Future.
Yeah, hello everyone. I want to shed a light on an upcoming challenge that is not yet on the radar of the HPC or AI community. Last week, I had a conversation with Michael Kagan, the CTO of NVIDIA, and even he seemed surprised by the thought that limited storage could cripple the growth of AI models. So the amount of data to be stored continues to grow exponentially, which means that in the next 2 decades, the storage industry needs to improve by 100 times storage capacity, performance, energy, and cost efficiency. We simply cannot build 100 times more data centers or spend 100 times more energy and money on storing data. Usually, when there is demand, the industry will accordingly react and eventually deliver. The problem is that current storage technologies fall short on scaling. They have reached the potential for exponential growth. This is why analysts point to the looming supply gap. Even in best case scenarios, the current industries couldn't deliver even the half of the demand. The requirements of AI data lifecycle will change our understanding of hot, warm, cold tiering. Huge amounts, maybe the majority of data will be born cold, whereby parts of it probably will be needed at a later point in time for various use cases such as training, tracking, or gaining new insights. Huge chunks of data need to be quickly warmed up. This requires a storage tier that is extremely cost efficient, long-lasting, sustainable, and still fairly performing. So the next slide, please. Storing information on a ceramic-based material isn't totally new. In fact, it's 5,000 years old. The cuneiform tablets testified the advent of writing in our human history. The modern version is a thin ceramic layer on flexible glass foils where matrices of bits are punched into with a laser stamp and read back with an image sensor. And because this is an inorganic material with physical holes or no holes representing zeros or ones, it's not prone to bit rot, even under extreme conditions. The massive parallelization of the write and read processes enable high data throughput. Using existing form factors and automation makes the integration in existing data center library infrastructure simple. The component we use for writing was developed 15 years ago for semiconductor manufacturing for maskless lithography. Today, it is a standard part of projectors and head-up displays. And we tested the tools from today's semicon fabrication, ion beam, electron beam, and this also works in our material. It would simply be too expensive to use it for writing data today. But in 10, 15 years, we can adapt it, and this will lead to the data densities required in 10, 15 years from now, and where current mainstream technologies cannot scale to. Next, please. From the perspective of latency, this new tier is located between HD and tape. Cost-wise, it is predicted to be far below tape. Ceramic data storage will close the supply gap, and some say it's even more, the enabler for AI unleashing its full potential. And with that, I hand it back to Philippe. Thank you.
Thank you, Martin. We continue with Horst Schelland, Technical Director at Savartus, presenting a talk about the resurgence of optical archive data storage to support AI workflows.
Yes, thank you, Philip. Today we have heard about quite a few storage technologies. It seems optical storage is forgotten, but actually is still here. And I want to talk about the new developments here and the new advances. So on the left-hand side here on this chart, you see the roadmap for enterprise optical storage. What you see is that the roadmap goes to up to 10 terabyte per medium by 2030. It means that between now and 2030, in the next 5 years, we will have a 20-fold increase in capacity. What that means is we are getting to storage densities similar to LTO. The goal here is to achieve the lowest media cost per terabyte in the industry. And I want to explain how this is achieved. One important item here with this technology is that we have backwards read-write compatibility through all generations. So if we are at a 10 terabyte medium, we can read backwards, all the way to the beginning. On the right-hand side, we see a cartridge as used in automation. It's a 12-disc cartridge. It has 12 optical media, and this cartridge has the same form factor as LTO. That is different from the past. In the past, optical has never been, when it comes to storage density, a leading technology. How are the capacity increases achieved? First of all, through a multi-layer disk, and then through increased linear density in the later generations. The new drive is in a half-height form factor, and it has a new laser design with multi-layer focus capability. The technology in real life is intended to complement actually tape solutions, and that is where the characteristics of optical, namely physical warm, are required. Next slide, please. So the case for optical today and what the benefits are today are secure storage through physical warm. It protects against many physical impacts, electromagnetic pulse, electromagnetic radiation. It's impervious to most disasters against viruses and malware. And it also, through physical warm, prevents data alteration. Added data or changed data is just done through versioning. Proven technology, we are using proven technology. It's based on existing 120 millimeter optical technology. What is new is the multi-layer and the advanced drive. Also, what is similar to the past is the longevity, larger or more than 50 years. The goal here is to achieve limited or no migration cycles throughout the life of the data. Again, I talked about the backwards read-write compatibility. The latest generation drive can always access all previously stored data. Acquisition cost on LTO level will be achieved with the second generation, which is 1 terabyte medium, which will be available by the end of this year. Typical power consumption for the system is under 250 watt per terabyte, and it will improve further with future generations. Use cases, all types of long-term archival storage to meet compliance and retention mandates. A seamless system integration via an S3 Glacier front end. And also, there is a managed offline storage available, which is a library with an RFID reader for the cartridges. This library has no drives. It is a network-connected offline library, and that really provides a true air-gapped storage. How this is managed is in the Glacier interface. With this offline storage system, we have an additional storage class, and we display this in the Glacier interface. Besides the standard storage class and Glacier storage class, we show an offline storage class. Next slide, please. How optical supports AI workflows. First of all, optical is an object storage target, and obviously optical is only used for inactive data. And in these workflows, it is then tiered from active storage. Well, first of all, it has to become inactive, and then it is tiered to optical. Data growth typically means an increase in storage and energy cost. This is where optical has significant advantages. And with the automatic tiering of cold data, we come to this low cost. It's very similar to tape. And we support the integration of sustainable storage media. The offline storage I talked about, and which also can be integrated into the Glacier workflow, has a power consumption under 50 watt per terabyte. For compliance and regulatory requirements, also optical will contribute. There is available an AI-enabled data access tool. And then integrated in the Glacier workflow, we have the immutable media, which is then used for standard Glacier and also offline storage classes. This concludes my presentation. Thank you.
Thank you, Horst. Now, Spectralogic with Ted Hode, Product Marketing Director, speaking about AI rising energy cost, why data centers will be turning to tape storage.
Thank you, Philippe, and thank you for everybody attending today. We really appreciate you being here. I think one of the things I'm taking away from all this wonderful content is that there's going to be a lot of choices as the compounding storage growth driven by AI happens. But I want to talk about a slightly different angle from everybody else today. We all know the potential for AI is limitless, and we're already seeing tremendous amounts of benefits in healthcare, education, transportation, communication, and home automation. And those areas will continue to kind of expand exponentially. Next slide, please, Philippe or Rich. But there's a little problem, and that is we don't know yet how the world is going to supply all the electricity necessary for all of the compute that AI is driven by and the energy that it uses. So here on this chart, that's basically data provided by the Electric Power Research Institute here in the US. The bottom blue line is data center energy consumption, and that top red line is energy production. And I put on there that it's relative because energy production is obviously a lot greater than that, but this is the relative growth in energy production. And so as you see around 2020, AI started to go mainstream. Artificial intelligence has been around for a really long time, but we started to see it really go mainstream, services available with the major cloud service providers, people rapidly developing new applications. And then, of course, as the decade continues, you can see that there's a dramatic spike in the amount of energy that data centers are consuming. And that's particularly, specifically due to the growth in AI. Well, there's a problem is that, like I said earlier, we really don't know yet where all that additional power is going to come from. And in fact, we're seeing already that organizations, cloud service providers, large data center operators who want to expand their data centers are being limited by the amount of power that a municipality can provide to them. And of course, the infrastructure and the capital investments required to increase that energy, that grid capability, they're very slow, they're very expensive, and they're very capital intensive. So right now, a lot of organizations, larger data centers, more sophisticated customers, major cloud service providers, they're trying to figure this energy shortfall out. And one of the things they are going to have to do, or they're actively involved in, is trying to cut the energy consumption, right? So at the same time, while AI is continuing to gobble up a greater and greater share of the data center energy consumption, they've got to find ways through other technologies, and storage is a big one, to save data. So next slide, please, Rich. So tape to the rescue. And I don't want to discount some of the other technologies we've heard about today, because they're also going to play a role. Like I said, consumers are going to have, or data centers are going to have, a lot of choice as the amount of data just explodes, and the industry in general is going to have to be creative. And I mean, the storage industry is going to have to be creative in satisfying the need to store all this incredible data growth. But, with the proliferation of power-hungry AI infrastructure, data centers have limited options for power savings, and tape is one of the many technologies that can help. And it's not just the fact that tape delivers the lowest power consumption. Again, what I'm comparing against here is mainstream storage technologies that are widely deployed, right? So comparing tape, as on the right here, watts per terabyte, tape is slightly above zero, and cloud is pretty high. And one of the things with cloud is this is an aggregate, of course, and cloud consists mostly of hard drives, between 80 and 90% hard drives, depending on which cloud service provider you're talking about, and then probably about 9% SSD or flash, and about 1% tape. And yes, cloud service providers do use tape because they have so much data to store. So that's the good news. From a watts per terabyte, tape can deliver the lowest power consumption. Again, it's mainstream, it's available, you can plug it in today. We also, on the lower chart, can deliver the lowest total cost of ownership, again, of mainstream, widely deployed storage technologies. Streaming performance, and I think Pete might have mentioned this earlier, that on a pure head-to-head streaming performance, now that's not random rewrite performance, that's I'm writing large files continuously without stopping. Tape is actually faster than hard drives. So hard drives have not moved the performance ball ahead, right? They're kind of stuck, even with the newest generation of hard drives using lasers and hammer technology. The performance of hard drives really aren't moving ahead very much, but tape is. So as the newer generations of tape come, there's been a leap in performance that has also mirrored the increase in capacity and density. Next, tape is extremely scalable. So we have systems that exceed 1 exabyte and beyond. And then lastly, as mentioned previously, there's air gap. Tape lasts up to 30 years on the shelf. And then there's the flexible consumption model. So we heard about tape, object-based tape, or cloud-based tape is also available. So it's not just a data center on-prem only technology. Thank you.
Thank you, Ted. IBM now with Sean Broom, tape evangelist and strategist, about the real cost of data storage beyond bits and bytes.
Thank you, Philippe. Next, thank you very much, Rich. As we have seen from active archive data has advanced to include tiering and data placement, metadata tracking, providing knowledge of what is in archives, and of course, how to monetize data with AI. But the real cost of the massive amount of data generated in the world is a little less obvious. For instance, 2.9% of global energy production is consumed by data centers. Now, Ted just gave a great overview of some of the shortfalls related to AI, but it's a little bit bigger picture than that. If you think about 2.9% of global energy, that's equivalent to the entire country of Japan every single year. Now, 20% of data center energy is consumed by storage, and up to 70% of that is cold data, or could be classified as active data, but very infrequently accessed. 56% of all the data is considered absolutely frozen. It never gets touched. So even with data accessible tape solutions, there's an annual savings potential of over $51 terawatts of energy. Now, think about that conversion there. If you convert that based on your standard US monetary value per kilowatt, that's a savings of $6.5 billion per year that the overall storage industry could reinvest into AI technologies, software, and methodologies to overall reduce the amount of energy gap that we're going to have. Next slide. Now, I harp a little bit about energy. Energy will continue to be a factor with the data centers. And as Ted indicated, tape and other technologies, future technologies, are definitely going to have an impact. Data centers with a focus on AI are quickly being classified by their energy consumption, which is currently by the number of gigawatts. I'm installing a 4 gigawatt AI station. But what's not seen are the byproducts of this massive energy consumption or requirement, such as the consumption of over 1 million gallons of water per day for these data centers. And every time they double, that amount of water usage doubles. That's a big impact. The storage being used is highly influencing to the energy. As we see on the chart from further data research, they anticipate that active storage medias, which currently we see as SSD and HDD, their energy consumption could double by 2030. Now, this is a little tough to see, so let's zoom in. One click there, Rich.
Whoops.
Well, it didn't come up, but that's okay. If you look at the very bottom of that chart, you can see a very tiny red line, and it's in the legend as active archive installed base. Now, that's tape, your optical technologies, DNA, and others that may come along. While the amount of data is expected to continue to explode on those mediums, the amount of energy they will consume is not changing. That's a big opportunity for the IT industry overall to embrace this. And why there will be other technologies besides tape. Dr. Vane states it best. All of the bugs and practicalities of access, scale, manufacturing, and supply chain have been worked out of the tape industry, and it's pretty reliable. Again, I'll emphasize, we're going to see others. Next slide. And the most missed aspect of technology is the end-of-life process. While this is becoming more important, and certainly planning in most regions is done at the end rather than the beginning of the process, we do know that the European Union has taken a lot of steps here. By placing data in the right tier and knowing the majority of data is archive data, the end-of-life process must be planned at the beginning of the acquisition process. Technology disposal processes must become a circular process while also supporting secure data disposition. We can't just take cartridges and say, yeah, just go recycle them, leave the data on them. There has to be a process and accountability. Now, seen here, this is one of the many processes oriented around disposal and the methods for data disposition that has been developed for tape media. Now, these processes can reduce the carbon impact of tape media specifically by up to 50%. That's a huge reduction, even when we consider that the overall carbon impact of tape is extremely low. And at a cost equivalence of the traditional methods like shredding and incinerating, it's a big encouragement to say, yeah, I'd like to take a solid process and secure my data, especially when you have to realize the results of incinerating polymers, and we all know plastics exist within everything, results in a nearly 3 times CO2e from the original weight of the polymer. That's pretty terrible. We need better ways, and we have to recycle. Tape's already ahead of that. Now, the beauty of this is for clients around the world, the process is fully accountable and monitorable. And that means that anytime data or tape conditions need to be recycled, they're not just thrown out there willy-nilly. There's a process to ensure that all the data is erased and provide regulatory assurance and carbon reduction accounting. And that's my presentation. I'll pass it over. Thank you, Philippe.
Yeah, thank you, Sean. And we conclude with Mark Pastor, Director of Product Management at Western Digital, presenting disaggregated storage architectures are key for AI workflows.
Thank you very much, Philippe. I'm going to wrap this up. I won't make a comment, or maybe I will, about saving the best for last. There's been a lot of discussions already about the whole AI workflow, and this diagram really just reiterates some of that. You can see that there is a storage pool area here called massive storage in Active Archive. And of course, that is the repository for generative AI. It is also the feeding pipeline for large language model learning and inferencing and things like that. So everybody agrees that there's a need for massive storage. And what I'm going to talk about is how, given that this is in the futures segment of the discussion for today, how the future is really here and some of the trends that we're seeing. Next slide, please. So as I think Philippe mentioned in his opening remarks, we are here concurrent with what's going on at GTC, the NVIDIA show on AI conference. Western Digital is presenting there, and what we are presenting is this architecture here that I'm going to talk about, and it's really about disaggregated storage. Now, the key theme for what we're discussing at the GTC event is how you can have external storage, external from the server is what I mean, being able to connect into an AI workflow and have that AI workflow feel as though that storage is every bit as good as local to the server. And that's really important because we've taken care of eliminating latencies. We're demonstrating how we can keep, any number of GPUs, H100s as an example, operating at their full performance capabilities. And there's no bottleneck associated with network or storage at all based on this architecture. The reason I bring this up in the Active Archive environment is because what we're seeing is, by the diagram on the lower left of this slide, traditional servers used to have it all in there. They had processing, cooling, memory, storage, etc. But as the servers are getting more and more sophisticated, particularly on the processing capabilities, what's happening is there's not enough room. There's not enough physical room left in the servers for storage. And so this is really fueling the realization of infrastructure that is actually taking storage, making it external for primary storage, as I just described, using SSDs over NVMe over Fabric as an example, which demonstrates that, very real-time processing capabilities that I described. But that whole architecture is now becoming something that's attractive for all storage, including secondary storage. And so we can have, large pools of hard drive storage, which can be cached to any of the other technologies you've heard about today, including tape and all that, connected, either through a NAS or object server, or eventually you may see a lot of direct network attached enclosures that can house the HDD storage. So I think the key message here is that as you disaggregate your storage, and Rich, you can move to the next slide, please. The benefits that you can realize is you can really maximize capacity and performance, capacity for hard drive caches, performance for SSD, and you can do that completely independent of the server technology. So you can work on the servers to tune your performance and your memory and everything else. You work on your storage separately. And by doing that, you optimize the utilization of storage. So there's been a lot of discussions about TCO from various of the speakers today. And I would say my only response is TCO, total cost of ownership, is a very personal thing. And every company has their own way of looking at it, and every company has their own specific needs from a balancing performance, accessibility of data, et cetera. And so as you look at these new disaggregated storage architectures, they help the TCO of active storage and active data by better utilizing the storage, because you can share it across multiple servers. It becomes a pool of resource that can be available across all workflows, and that further helps support lowering the overall cost, in addition to a variety of other technologies that I won't speak about today, but that are going into helping that active tier of storage become even more and more affordable. So the bottom line is disaggregated storage is really aligning with data center infrastructure trends that are actually happening today. And I expect this to happen. It's starting really at the high performance primary storage tiers, and I expect this to move down as we go forward. Thank you.
Thank you, Mark. And I have one question. I wish to insist on this, a pretty comprehensive one, and many of our last speakers can answer, I'm sure. What about adding AI in optical storage, disk array, tape library controllers, tape drives, all of these? Because we speak about, during these 2 hours, a lot about serving, connecting, how can AI engine can leverage, but what about adding some AI capabilities into some storage devices and units? Sean, Martin, Ted, Mark?
Well, I would say that's a great question, and I don't know if my audio is coming through. I was getting a little choppy, but I'm going to answer it very briefly. There are actually intelligent capabilities in storage devices themselves today, whether it be SSD leveling, whether it be OptiNAND technologies and tiering and things like that. So I think those internal little tools that help balance performance and reliability of devices can just get better, and some components of AI may very well help with that.
Good. Martin, Hertz on the optical side?
Well, I think on the data access side, there are quite a few options for an AI-enabled data access tools which look across, for instance, different applications. I think that from a user point of view is very critical.
Good. Sean, Ted, on the tape and tape library part?
Sure, I'll comment. We're already seeing metadata and data cataloging being very important. I don't see it integrating into tape drives and tapes themselves. However, the formats and the software controlling these entities is growing very quickly to realize that on ingest, before storing data, metadata associated with how to catalog and where data should be utilized is already beginning to burgeon, and it's the next generation of software that's going to drive us probably clear into the next decade. So it's already happening, but probably not at the hardware level.
Good.
I can probably add a little bit to that as well.
Please.
So again, I think Martin's right. From a strictly tape drive perspective, the technology enabled, or I should say, think of it as AI-enabled tape, really happens upstream a little bit. So again, if you're thinking about cloud-based tape, tape storage as a service, S3 to tape, that interface that happens before the actual tape drive or tape library is where that metadata intelligence, that acceleration of availability of the metadata, the tiering, all those kinds of things are happening at the intermediate level, the middleware level, and there is active all kinds of active development happening to basically have tape as a backend doing what it does best, but in the middle, kind of making sure that that data is more accessible and it is built to satisfy the needs of the AI archiving, the AI model, long-term storage of the compliance data that's being required for AI, etc.
Good. And Martin, you wish to add something?
Yeah, so I would also agree. that keep AI away from the bottom of the storage. I think especially in now in these times when AI probably will change reality, so we have a chance to have let's say a last immutable copy of what we consider as knowledge or as reality or as facts.
Thank you, everyone. It was a pleasure for me to present and moderate this online conference with all of you. Back to you, Rich.
Yeah, thank you very much for everybody who attended today. Thank you very much to our speakers. And a very special thank you to Philippe. Great job. Thanks for running the Q&A and for introducing everybody.